Hi, a warm welcome to you. So in this video we will see how to derive law of cosines. In the last video we have seen how to get the formula for law of sines, and also we did some examples to apply the concept to understand it better. Please remember that law of sines and law of cosines can also be derived in more advanced and also in other ways. This is one of the way what we are learning to basically understand how we have derived law of sines and law of cosines, and by this time you should have clearly understood that these two laws provide relation between the angles of the triangle and sides of the triangle. Okay, let's go ahead with law of cosines. If you remember law of sines, how we have derived, our whole focus was on how to find out this altitude. You know why we have actually bent upon working only with altitude? Two things. Because we know that area equal to half base into height, and my height is not given and it's not a right angle triangle, so it becomes very tough for me to find out how the height. So whatever the trigonometry concept I have learned recently, I can implement that and I can see if I can find out the height. And another point why we always stick to height in one of derivations, these derivations, is height gives you, if you are able to find out the height, that means you are actually creating two right angle triangles here, because you know that the altitude joins the vertex to the opposite side at 90 degrees angle. That means now this triangle, there is a triangle ACD, let us say if this is D, and BCD, both are two right angle triangles. Okay, right. Now how we want to derive this is pretty simple. See here, there is H, there are two right angle triangles. If from this triangle I can say b square equal to, b square equal to h square plus this side. Similarly I can say a square equal to h square plus this side. But how we want to take it forward, let's see. Let me say this is equal to d, so that it's easy for you. Okay, let me take first triangle ACD. Okay, triangle ACD gives me AD is equal to, this is a right angle triangle, hypotenuse is b square minus this is h square, square root of this, right? This is what I can get from for AD. Similarly, if I come here, triangle, this triangle is, let us say triangle BCD or BDC, whatever it is, I say BCD. Okay, triangle BCD gives me DB or BD is equal to square root of, again, a square minus h square. Now you can ask me, why are you doing this? Because I know C is nothing but sum of this. So I know C is nothing but now equal to square root of b square minus h square plus square root of a square minus h square. Now suppose we want to find out with respect to b. Okay, so what I will do, I will again consider this triangle. What is the triangle? ACD. I will say b square is equal to, equal to b square equal to h square plus, how I can write this part? Nothing but c minus of this whole thing, right? So I can write here square root of b square minus h square equal to c minus of square root of a square minus h square, right? So I can say this as it is, c minus of square root of a square minus h square whole square, right? Now simplify this. What happens now? B square equal to, let me change the color. Yes, I will. Okay, this is nothing but equal to b square equal to h square plus, this is a minus b whole square, that's nothing but a square plus b square, square root will go, so this becomes a square minus h square minus 2ab, nothing but minus 2 into c into square root of a square minus h square. H square cancels. So what is that we are left with? B square equal to, c square plus a square minus 2c into square root of a square minus h square. Now let us see what is the square root of a square minus h square. So if you look from here, square root of a square minus h square, and what is the known value? A. I don't want to go for h, right? I want to go for a. So what is that? Nothing but cos of b. Cos of b is nothing but equal to square root of a square minus h square by a. So can I say square root of a square minus h square equal to a cos b? Can I say that? Yes, I can say a cos b. This gives me b square equal to c square plus a square minus 2ca cos b. Similarly, what you can do is, instead of taking c, if you take the base as b and create an altitude h1, and you do the same way whatever we have done, you will get c square equal to a square plus b square minus 2ab cos of c. One more is a square equal to b square plus c square minus 2bc cos of a. This is nothing but law of cosines formulas. These three formulas are known as law of cosines formulas. Now remember, these formulas can be applied only two conditions. First conditions, when you know a comma b comma c. Second condition, you know two adjacent sides and the included angle between them, included oops, no, I don't want to do that. Let me just erase that. Two adjacent sides and included angle between them. These are the only two cases when you can use law of cosines. Please remember that always, right? If you cannot use it, then you can go to other methods. Okay, right? These are the two times. One, when all the sides lengths are given to you, that means you know a comma b comma c. And another thing is two adjacent sides, like you know b and c, you know cos a, or you know c and a, you know cos b, or you know ab and cos c. Okay, this is the law of cosines we have derived. Let me just summarize that before we close. Okay, we have taken a triangle. Our pursuit was always to find out what is this height, how I can leverage trigonometry to say this height. Okay, we started with height and we are finding so many things. So we took a triangle, and another reason why we have taken altitude high, because altitude makes it two right angle triangles. So I can leverage the right angle triangles and I can derive the law of cosines. Okay, so first triangle, I can find out part of c, that's nothing but AD, nothing but square root of b square minus h square from Pythagoras. Similarly here, this part dB is equal to square root of a square minus h square, again from Pythagoras. But this sum should be equal to c, because that's what is definition. AD plus dB equal to AB, nothing but equal to c. So what we did then, now where we want to apply the formula here. Now suppose we want to cos b, we want to find out what we did. You want cos b, so we started with here and said b square is nothing but equal to h square plus this length. What is this length? Square root of b square minus h square. That's nothing but equal to this length, c minus of square root of a square minus h square. After that we simplified this, we have manipulated it, and we found that c square plus a square minus 2c into square root of a square minus h square. but h is a not known to me, so I don't want to have h there. Okay, right. So what I did then I went back to this triangle and find out where is square root of a square minus h square. It is there in either tan or it is there in cos, but tan will make it more complicated, so I went to cos and I found that cos b is nothing but equal to square root of a square minus h square by a, which I have substituted to get these three formulas. B square equal to c square plus a square minus 2ca cos b. Now instead of AB, you take your base as AC and you do the same thing AC, right? That means you are doing it for B, right? Okay, then you will be getting, instead of the formulas in the two ways, one is c square equal to a square plus b square minus 2ab cos c, and you can see the pattern here, right? B square, that means you want to find out related to cos b, you say b square equal to c square plus a square minus of 2ac into cos b. Similarly, you want c square, what you will do? C square equal to a square plus b square minus 2ab into cos of c. That's what you have shown here. Okay. In the next video, we will do some examples on law of cosines, and in the advanced concepts, we will see derivation of law of sines and law of cosines in another way. Okay. Right. Thank you. Thanks for watching. Bye for now.